So I wrote down some notes here. So pretty much there's two different ways. I'm gonna study a library that's called NanoVG that someone recommended on Discord. And yeah, I wrote down some steps there that I think will be the best. Obviously, I'm gonna have to think about it. But from what I've researched, there it seems to be two different ways to render text that are most used. One of them is texture-based rendering, and the other is sign distance field. And texture-based, you just both of them use a image, but with texture, the image is a bit image, so you start the bits of the colors, I think. And with sign distance fields, you use a vectorized image, which is like a NSVG, for example. So I think on both approaches, you load the font, which is the images of the font, either vectorized or the bitmap image. And based on that, you draw Bezier curves. I don't know specifically the details, but that seems to be how it works. And then based on that, you use the fragment vertex shader, and then obviously you draw the points. So it seems that the sign distance field is the one that is most used, and is the one that this NanoVG uses as well. So what I'm going to try to do is to study the library, and then, because NanoVG is a GUI library, it's not only text. So I'm going to try to remove a bunch of things and just leave the functionality for the text. And then I was thinking about what is the best way to integrate with the stuff that I'm doing. And the conclusion I got so far is that it's not good to separate them, and I should try to incorporate both of them. And then I thought about that it's probably more optimal to render the text in the same program and in the same drawing call. No, not drawing call, but like simultaneously with the label. So couple them together. Because obviously I'm going to use the label to do that. But then like the question is, because I might want to use labels later or text later, so I don't want to necessarily couple them. So I think the way that I'm thinking about doing now is just create a class called label, and then add one of the attributes of the sphere geometry to be the value of the label. And then inside of the rendering call, the rendering context, or rendering cycle, I'm going to put a condition that checks to see if the sphere geometry has a label, or if the geometry from the mesh has a label or not. And if it has, then I draw the label for the mesh. Which is going to be, so I'm going to have to incorporate, this is one of the things that I was thinking about, because I'm going to have to incorporate on the same program. I was thinking about doing two different shaders, but then the problem with that is obviously on the rendering cycle, because of the way that I did things. I don't have to, but it's easier if I just put all the functionality on the program, on the same program that I'm using to render the sphere. Because then I can just put one program, like I can couple them together in the same program. If I do it the other way, then I have to add some extra functionality on the rendering cycle that is going to check to see what kind of program it is, or I have to think about a way to couple or to put the label. I think that's how I was doing on 3JS on the front end. You can open here, you create a tree mesh, and you create a class for the label, and then you create a mesh, and then you put them. I was putting them together with the group. So the way that it works on 3JS, because I was using another library from 3JS, which is the stacks library here, that comes from Troika tree text. So this one inherits from mesh. So you create a separate different mesh, but based on the way that they did 3JS, then I don't think it's going to be that bad, because they're probably going to use, or I think I wasn't using the same material, but now that I know like how it works better, I could change the code on the front end to use for the text and sphere to use the same material, and then you wouldn't create two different programs. So it's not that big of a deal, I think. But based on the way that I'm doing things, I think it's going to be more optimal and better to just try to render them at the same time. I think it's going to be more efficient. So one way that I'm thinking about, and this is the question that I know I'm going to try to figure out now, is because it depends on the way that the text is, the buffers are set up. So the way that I'm thinking about, doing is to figure out how do the shaders, fragment shader and vertex shader work for NanoVG. So I can remove the code and add the functionality into the other shader, and then make it based on conditions. And based on that, I obviously can check to see if the thing has a label or not, and then I can just add a new attribute on the sphere geometry class that is gonna create the data to pass to the buffer that is gonna draw the label. But depending on the way that the buffers are set up, then I'm gonna have to create something else, and I'm not gonna be able to do it. So another way is to just incorporate the functionality on the label class to render, so I can render them outside of the main loop. Because the way that I'm doing the programs here, I loop over all the attributes for the mesh, which are gonna be initialized on the geometry. So like one way is to put an additional attribute called label on the mesh. But if it's not the same, then obviously I would have to put some control flow logic here to check if there is a label or not, and then based on that. So that's one way. The other way would be to do it in the same way that the index attributes being done, that I do it outside, and then instead of creating a buffer geometry attribute, I see whatever I figure out whatever way they use to create the NanoVG thing, and then I just transfer the functionality to this class and create other functions. They're just specialized specifically for the. I think that's probably the best way, specifically for rendering the label. So I can create a condition here based on the mesh, and I think on the constructor, I create a condition based on the mesh and then put on a separate function to set up the buffers and everything else just for the label. So that's what I'm gonna try to do here. So the first thing that I have to figure out is how does this thing. So I wrote a couple of steps here. I think the hardest part about this is figuring out how to couple or transfer the functionality for the shader. The other approach is obviously to use a different shader and then create a different program, but I think at some point maybe I'll have to do that. So this is something that I was thinking about before as well. And for now, I changed the way that I'm rendering. Not changed, is the stuff that I said on the last stream. That because of the way that I'm doing things, like this is the tricky part, is figuring out what is the best way to update everything and to add flexibility on the programs class to handle the variance of the data that is gonna be, that is gonna force different programs and stuff like that to handle different data. One thing that I thought about since last time is probably a good way to optimize the rendering would be to every time I create a group. So I was thinking about like making the functionality dependent on the group, because every time that I create a group, it makes sense that the group would render everything in the same way. So I can make the functionality of the optimization on the programs based on whether or not it is a group. And if it is a group, then obviously I set up a uniform buffer object and set up batch rendering and all the other stuff. And then I just treat the group as one unit, even though it might be several different things on the visualization. And that way I can separate the meshes. I don't have to couple everything together. I can just create several different meshes, and then I have more flexibility to decide whether or not things are gonna be rendered by the same programs. Because then obviously I can, on the external parts of the code, I can just remove and add meshes to groups, and then based on this functionality, it's gonna figure out. But then the question here is that it's kind of annoying because I would have to think about this function here. Like the way that I was thinking about doing obviously is put else if statement here. And this is another thing that I realized is because I wasn't sure on the programs class, how would I do the functionality to update the materials because of the way that inheritance works on C++. So on the function, I have to specify a type to set the things, but the type is the base class, which is the material, because obviously I'm not going to know which kind of mesh it is. And this is the issue, because if I specify on the function that the class is going to be a material class, then I can't access attributes from classes that inherit from the material class. So mesh basic material inherits from material. So if I want to change a member variable from mesh basic material, I can't do that because the compiler complains because the type is material. So the way that they did it on the other classes, and I just realized because of the main functionality here, is to just put these functions here that use dynamic cast to figure out what kind of type it is. So you can just do that and then put the functionality. And that's how I'm doing now to update the materials. And I was thinking about, so now I'm just putting the opacity and diffuse because all the meshes are gonna have a color and opacity. But later on, once I put more stuff, then I'm gonna have to make based on what kind of material it is, and then I'm gonna set all the uniforms. So one thing that I was thinking about as well is that because of something that ChatGPT told me some time ago, that OpenGL calls are expensive, but I wasn't sure how expensive they are. And this was the question that I had, because I was thinking about creating a queue for the materials, because you don't have to, it's better if you, and also this thing made me realize that there might be some variable on 3JS that is not used. I don't understand very well, like why do they have that variable, but you don't need to update the uniforms if the high-level classes don't change. So it's more optimal to just update once, I think, on the beginning, the initialization, and then only if the attribute on the class, on the mesh, or the material changes, then you update the uniforms again, because the draw calls are expensive from OpenGL. Like the update calls from OpenGL are expensive. So the question is, how do you check if the member variable of the material class was updated? And then one way is to create this variable here, which is the way that I'm doing now. And then every time you change something, then you update the variable, you update the value of the variable, and then obviously that's signals that something changed, and then you update the uniforms again. But the downside of doing that is that you have, if you just have a Boolean variable, you have to update all the uniforms for the class, and you can select exactly what member variables were changed to optimize. So I was thinking about creating a queue and making it based of a string, because I didn't want to deal with the templates. So the way that I thought about is I'm just going to create a string, and then based on the name of the string is going to be the same name of the member variable, and then I can create a function that matches the string with the variable names, and then adds the functionality to update the variable. And then I create a queue to add the stuff to the queue that was changed. And then in that way here, I would be able to just loop over the queue and then just update the values of the variables that actually changed. So the question about that is whether or not it's about the time complexity, because like in one way you have to update all the uniforms, so the cost is going to be the cost to update, the cost to calling OpenGL functions, and then ChatGPT, and then I realize based on ChatGPT answers and like thinking about this is that there is another component, which is the synchronization of the GPU and the CPU. So as you're executing the code, you're transferring data from the CPU, which is the normal code that is being executed, and the GPU, which is the code executed by OpenGL. So the way that OpenGL does things, and because of the way that the GPU works, is on parallelization. So it does everything the same. It's kind of like, it's similar to asynchronous code in a way, but it's like using different threads to update everything. And the question is that like OpenGL allows you to continue to execute the CPU code while it executes the GPU code in order to optimize, as far as I understand now. So like the bottom line is that I don't think it's worth it to do it with the queue unless you're going to update a massive amounts of uniform, because the cost of the queue is going to be just the ON of the looping over the queue. and it's just gonna add a bunch of complexity. So even if it is more efficient, I think for now that is not worth it, because then I'm gonna have to change all the functionality. So that's the reason why I'm doing this like this now. So, and I added already functionality. I think I'm just gonna do colors for now, for a long time, for the fragment shader. So I'm not gonna think about this too much, but I just added the functionality to the class to update this value every time that something is updated. So that way it refreshes the material only when something is updated, or in the first time that it's rendering. So I think that's pretty much all that I did so far. And I think I'm probably not gonna, this one I was gonna do it if I wanted to set, like I said with the queue, but since I'm gonna set all the uniforms every time, I think I'm just gonna use this one. So I'm just gonna remove this. So the idea that I have now with the steps here is I have to remove all the code that is not related to the text. Then I have to understand how the shaders work with the text from NanoVG. Then I'm gonna put the fonts on the assets folder, because obviously the structure of the project, I'm already putting the shaders there. So I'm gonna have to change the relative path that they probably use to load the fonts in their codes. Then after I do that, I have to understand the whole pipeline, because they use NanoVG is a GUI library, so they use a context, which is a struct, which I briefly looked into. And then based on that, they keep track of the states with the context. And then they allow you to draw everything. But for my case, it's obviously not very good, because I just want to incorporate this on the other thing. So the main thing that I have to understand is at what point do they load the shader? Actually, I don't need to understand that. I just need to change the shader code so that it works with the other shader that I'm already using. So one thing there's another concern that I have that I'm not really sure is that if I put if-else statements instead of the shader, do I have to do in the same way that they do it on 3JS, where they put the logic on in 3JS case, JavaScript, which is a ternary that is gonna see based on the value of the class if they're gonna add functionality to the shader by incorporating the strings. Because if I have to do that like that, it's gonna be a lot more work, because I'm gonna have to change everything. Not gonna be able to do it just on the file. So the question is, if I put these if-else conditions here, do I need to specify on the high level outside of the shader if the shader is gonna use this or not? Because this logic is gonna be on the program, obviously. Based on the mesh, I check to see if the mesh or the material has these different properties. So I think I'm gonna do based off the label, obviously. So if it has the label, then I put all the functionality on the label. And I think that the name of this is polymorphism. So polymorphism, as far as I understand, is when you're gonna do things the way that I'm thinking about doing now, where I'm gonna put the value of I'm gonna make one class should be the value of the variable of another class, instead of inheriting from the class. I think that's probably better. So I'm just gonna test based on that, the value of the label, and then if it has the label, I think I'm gonna put all the functionality to do stuff related to the label on the label class, obviously. But this is the thing that I'm not really sure. I think this is initialized on the first function there. I created a different project as well, a different folder, just so I can remove a bunch of stuff and then keep the other one. So probably a good idea is to put everything on SkyDraw that this stuff uses. The way that I was doing on 3GS with the other class, the Troika Tax class, is to so that class inherits from a mesh, and I think this is the best way. So you initialize the class itself with a relative position. I think that relative position is going to be dependent on the sphere, but this is the thing that I'm not really sure though, because I think it kind of has to be. So you have the position that you initialize the class with, which is the position of the coordinates of the object in relationship to itself, which is the relative coordinates from the object. And then the way you move the object in the world is through the object 3D position. So I'm thinking about creating the... Actually, if I put on the sphere, I don't even need to... I just change the position of the mesh from the sphere, and then it's going to change both of them. But then that's the question, is what is the best way to connect them? So like, how can I make sure that... the thing is gonna be, I have to understand the buffers. So how do they structure the buffers to update and the variables? This is the annoying part, because I'm probably gonna have to change, and in order to do that, I'm gonna have to understand everything. So I'm not really sure if this is the best approach as well. Like maybe it's better to just do it on a suboptimal way, and then I just use this code here, because then I can save time. But usually that's not the best decision, so it's probably better to just take the time and then figure out what is the best. Because I have to... It's better as well, because then I'm gonna be forced to understand how everything works. But it's gonna take a long ass time, I think. So it's probably the best thing to do is just to write some SkyDraw, the stuff that they use here. The thing is, I don't need this. There is an example here that they do draw label at this function here. Maybe it's better to go. So they designed the library to be similar to the canvas from HTML5. Assume this is on the context. NanoVG state holds the information for the fonts, I think. I have to clarify what exactly is going to be the structure though, that's the thing. I think that the tricky part is figuring out how to couple the position of the label with the position of the sphere, because it's going to depend on the way that I have to set up the buffers. If I'm able to, if the buffers are similar, maybe not even if they're similar, because I can do the thing that I was talking about where I can separate the logic. I just create another function to, based on the condition of whether or not the class has a label, because this is the thing that I was thinking about as well. If I do it like this, then later on it allows me to put labels. It's going to become a lot easier to put labels on the edges as well. So, but the only way that I'm going to be able to do that is if I put them on the same class, but I allow some flexibility, so that the position has to be relative, I think. Because the question is for the line. So the way that Bezier curves work is you have two different points, the from and the to. It's going to be the origin for the curve and the final point. And then you have control points, which are points in the middle of this path, or somewhere along the line of this path that are used to create curves on the curve. And the way that sign distance field works, as far as I understand now, you have these Bayesian curves, and then you calculate the distance from other points around the surface of the curve. And then based on that, you create a gradient of the pixels that are going to be drawn. So, and there is a problem with that because then sharp curves are not very good because of this gradient. So they don't scale very well. So in order to solve that, there's this other library here. But I think this is just, because the downside of this, if you use multi-channel to make the sharp curves better, sharp corners better, you lose on memory. So, and I think it adds a bunch of complexity, and I'm not really, like, the main priority that I have is performance, like how fast it is, not how good it looks, I think. So I value more performance than how good it's gonna look. So I think I have to go from the it's better to go from the beginning here, because that way I'm going to understand how the context is done, because they do everything based on the context. There is a function here somewhere that's I remember that is the same or similar to this one. See if I can find here. I think, yeah, it's a function that calls this function here. So maybe it's here. There were some other files that I deleted because they said that they're outdated. So I'm not sure if it was on one of those files. Maybe it's here. Yeah, here. So the flags are this thing here. This is another thing that I want to understand is the anti-alias, because I'm gonna have to do this for the other stuff as well. So they pass as flags. So this is the function that is going to be used to draw the thing. Oh, this is actually a problem, because the way that I'm rendering the sphere is with the indices, because they use indices. So the call is probably going to be different. Because when you use indices, you have to call the draw elements call. And then you pass the buffer with the indices to draw. So set up the VAO that holds the state, and then when you call GL draw elements, you pass the count that is based on the indices data. And then OpenGL uses the VAO to draw everything. So if they use if they draw with triangles, then I think that is another call if we're gonna draw triangles, another call to OpenGL. But the problem is that if they do another call, then I can't really do them on the same. Yeah, I guess this is a question. I don't think I can do them on the same regardless. So, like on the same draw call. I would be able to do that if I change the whole way that the class works, so that the data that I'm sending for the indices not only has the position, but also has the label stuff, which I think is going to be too much work and it's like not worth it. So obviously the other way would be to separate them, but so I'm not gonna do. I don't think I think it's better to create another class, the label class, and then based on whether or not the mesh, the geometry has the label class, I create some separate functionality that renders everything for related to the label. So this is a similar function to the one that I'm using there on the other one. And you're probably just getting the uniform locations and the data for the uniforms. And then based on that, they are setting up the buffers, I think. The hardest part is thinking about how to structure the, because it's gonna be a lot easier if I use a different program. But then the issue is that I can't couple them. Like I can't make it, because the way that I'm creating the rendering cycle, I do it based on the mesh, and then I create the programs based on the mesh. So yeah, I can connect them based on the position, but it doesn't feel very good to me. So I would be able to just create the label class and then extend or inherit from the mesh on the label class, and then just create a new program for the label, and then just put some functionality inside of the programs class that checks to see whether or not the mesh is a label, so I can cast with dynamic cast the same way that I'm doing there on the rendering cycle. Or instead of doing this one, I can create another function, and then based on the control flow here, I put the if object is label, then I call another function, and then based on the other function, I create another class. But then the thing is, the tricky part is both the optimization and the position, because the label obviously has to be coupled with the. It would be better if the label is coupled with the geometry that represents the label, because that way I think that there is less space for mistakes, and it's obviously going to be easier to optimize. But obviously I can create some functionality inside of the programs class that optimizes the draw calls to. I can create another data structure inside of the programs class, but it doesn't feel very good to do that. So create a map for another map, for example, that connects labels with sphere meshes or other meshes that the label represents, and then based on that, I loop over that. But it doesn't feel good to do that, because then I'm gonna have to change everything here. So the best way is probably to. The problem is, like, I might waste a bunch of time changing everything to do that. So the question is, what is the middle way? don't remember which file they have the shader code, but I remember that I've seen. Obviously, they need to have the shader code to render things. Forgot to start this. I also think it's better to separate the it would be better to make the default to be the default color for the label to be the same as the sphere, but then give the option to make a separate color for whatever reason. They're using GL draw arrays, so it's a different draw call, I think. Yeah, to draw the indices, you have to use GL draw elements. Let me think about it. Because here I'm looping over the meshes, so I'm mapping the mesh ID with the program. So mesh ID is not, it's just program ID because this state is stored on the programs class. So there's a map that maps the ID with the mesh program. Here is the ID and then the program. So if I do things the way that I'm doing, the label is going to be in the same program as the sphere. So it's going to be the same program mesh here. But then this is the problem because I guess I can just I can make a condition here. I could just put different so maybe the best way to do it is to just check to see if the geometry of the mesh has a label or not, and then if it does, then I just do another draw call here. I think that's probably the better way. So that way I don't have to change anything on the other one, because here I'm using it's gonna go on the other. Hey, what's up, man? It's gonna go on this one here. So because the sphere uses indices, so it uses this draw call here. But it seems that to draw the text they're using this one here. Draw arrays. The thing is I wanna change as least as possible so I don't waste a bunch of time. Obviously I want you to understand how they do it, but it's much better if I can just copy paste all the code and then don't worry about this. So if I can transfer the functionality in the exact same way that they do it. There's two components. One is the program, how to structure the program class so it has all the functions to create the buffers and everything else. And then just add the functionality inside the rendering cycle. If the mesh has, if the geometry has the label, I just add some stuff here. And then based on that, I do the same stuff that I'm doing for the other ones. So the other question is how to structure the label class so that I make sure that ideally I would start up in the beginning, that's the thing. So I create the sphere mesh, and then after I create the sphere mesh, I just update the value of the label. This is another thing that I'm thinking about now is what is the best way to structure when it comes to memory. So it's probably better to create a function so I don't have to think about this. So for example, one way would be to create a shared pointer that is the label in the class that is going to be a member variable, and then I initialize the thing outside. But that's kind of the problem, is because I have to think about, once it gets to time when I'm going to set up everything else, I'm going to have to think about how I'm going to get the data and all the logic of the UI with the data. And I don't want to think about if I can do it in a way that as I initialize the mesh for the sphere, right after I can just call one function and then don't have to think about memory or anything else. And the label is just initialized based on the relative position from the sphere. Then it becomes easier, because here in the way that they do it on the example, you have to call a bunch of stuff to draw the label. So I want to avoid having to do that. That's what I'm trying to say. So probably on the label constructor, I put this stuff here, and then I just change the values. So as I build the class, I put default values here that are going to be the same as the sphere. So this is another question, because the label is going to depend on data as well. So I have to think about what is the best way to... I think the best way is to create a value. So I have the label class here. So the best way would be to put here, I think. This is another question: do I make it public or protected? I think this has to be public. As public. I'm gonna include the thing first. So I think this is probably the best. Initialize like this, and then I create another function that sets everything up. And on the function I accept the data, or yeah, on the function I accept the data. So it's obviously I'm gonna have to figure out. It's gonna be easy to figure out how to check if this was initialized or not, and if it has a string or not. You just ask ChatGPT or something like that. So the main thing that I'm thinking about is because the labels are going to be dependent on data that I send outside of the class, and that's going to be just later on once I have figured out the other stuff. So that's why it's kind of tricky to think about. But probably the way that it's going to work is that based on data, I create the graph structure, and then yeah, the labels on the graph are going to be based on whatever data I get, on how I want to classify things. So I think the question is whether or not I change these functions for creating the geometry to also add the label initialization, or I create another function to initialize the labels. Because if I create another function, it's easier, but there's a chance that I forget to call the function. It's not that big of a deal, because obviously you can create another function later on the other project that connects both the creation of the sphere and setting the label. So, but I think that it leaves more space. So obviously it's the trade-off between flexibility, and I think not sure what will be the word, comfort or security. Because if I initialize the label as I create the sphere, then obviously it becomes less likely that I'm going to forget to initialize all the spheres with labels. But then the downside is that if I want to create spheres without labels, then obviously the middle way is to put the default value. Or actually, Yeah, I don't need to. Or I can test. I can just pass something here, and then the thing that is kind of annoying is I'm gonna have to think about all this other stuff if I change this function. So obviously I can receive a string here, and then based on the string. But then it becomes like, what about the memory and how I'm going to change all the other stuff? But maybe that's the best way. And then inside of this function, I just initialize the label with whatever string is passed here. The problem is that this is not going to be... I think this is going to be annoying because I'm going to need a position as well. So obviously I can put a default position that is based on the sphere position, but then I don't have flexibility to set outside. If you want to change the... Maybe it doesn't matter that much, because it's always going to be relatively the same if I want to put the label. It's the distance from the sphere to the label is relatively the same. I think it's not gonna... So maybe I can make a fixed value, but I think it's better if I... But if I do like that, then I need to... So like the amount of parameters that I have to pass here are directly... Is pretty much the parameters that are required on the label initialization, the constructor. And the constructor is going to depend on how the buffers are set up. So I think it's probably better to just clarify the pipeline first. And once I understand more, then I can think about this. But there is so far several different instances where I get the same kind of thing. I think it's just something like from the way that the universe works, which is kind of paradoxical in the beginning. Like it feels that you have to understand the thing in order to be able to do the thing. So I'm trying to clarify what is the best way to go about it, because I have to understand these two different sides. One side is the program and set up the buffers and the optimizations later on the shaders, whether or not I'm going to couple them with the sphere and how I'm going to do that. And the other side is the class construction of the label. So I'm not really sure which way to go about it, because here is kind of confusing as well, because of the way of the context, and then I'm going to have to remove a bunch of things. Not really sure what is the best approach. It comes down to what questions to ask here. Because the thing is that I don't want to pass. Maybe that's the best approach. To just pass and start testing a bunch of stuff. I think the shaders. I should figure out where the shader code is at, and then try to understand the shader code. Not sure if it's... So these two headers are from two different libraries, I think, and they are used to load the fonts, as far as I understand now. Maybe what I can do is just use other functionality as well. Just realize this. So another thing that I can do is so I have less work to change everything. Inside of the program class, I can make functionality on the constructor that if the class has a label, I just create another program, and then I just use another variable. So I do the same functionality here. I can put all this stuff. think I'm gonna remove this because I was doing this to test whether or not it's gonna work. If the problem was the file, the way that I'm getting the file, but now I know that it's not. So what I can do is just create another variable in the program class that is like program label, for example, a label program. Then just put this functionality here to like build program. I can create a function that is called build program, just pass this functionality there. And then I can do the same thing just for the labels. And then I just use another shader for the labels. Maybe that's the easiest way. Because then I can just copy paste everything that they do there. The main thing is the functions. Because they use a bunch of functions based on the context. The biggest problem is the context. I think that's the biggest thing, because they are attaching the way that they draw the labels with the context on this library. And that doesn't make sense for what I'm doing, because I have to merge the context with the other stuff on the render. So I guess that's the points of confusion that I have now. I have to clarify this. So how can I ask questions about this? I have to decouple the context that they are using and then just leave the functionality for the shader and the text separately. So it's gonna be here that they create the program. Render flush. Now obviously I'm gonna look at the function and try to figure out, not try to, I am going to figure out, is just look at the function. Or maybe maybe it's not this one. Oh no, this is the one that is used to draw, not to build. But I can see how they're doing the buffer setup here. So they create a uniform buffer. Oh, the other thing that I want to see is what kind of header that they're using. So they use this one, which probably uses, because when I see if I use GLAD, I know that they use GLFW, but I'm not pretty sure if they are using GLAD as well. I think they're just using GLFW and then they're getting the context from GLFW. It's weird that like I'm getting it's not highlighting the color, so I don't understand. Maybe it's because of the way that they are inheriting everything, or including folders. So it's gonna, once it compiles, it's gonna put the color there of this stuff here from OpenGL, because it's not figuring out. So obviously I can just include the GLAD here, I think. It doesn't look like they are including anything. Let me go back here. So GL shader. So it's probably when they create this thing here. I remember seeing this one. I don't remember where, but yeah. So this is where I saw the shaders. So this is the shader code. I think I'm just gonna copy paste this on the other file. So probably the easiest way is to maybe I should do a gradual way where I just copy everything first, then see if it works, then I try to merge if it makes sense. So the easy way is just to change the functionality on the program class to check based on whether or not the sphere has a label, or if the geometry class from the mesh has a label. And then based on whether or not it has, I just create different functionality on the program class itself to handle so create other program, other buffers and everything else. Because then I can just copy paste here and I have to think about it. And then it's going to be pretty much the same logic. So, because on the label constructor, I can put all the variables on the label. I can translate how, probably that's the best way. So I looked at the way that they design the functions and how the connection of the variables inside of the structs that they are using to create the thing that is going to hold the state of the text, how that translates into into updating the buffers, into updating the program variables. So that way I can just change the that's probably the best way. So I decouple the functionality from the context by understanding what variables that they're using, and then I just put the variables inside of the label class, and then figure out the logic that they're using to update the program, and then I create probably that's the easiest way. I think I'm gonna do like this first, and then if it is bad, then I just gradually convert to merge the two things. So I'm gonna copy the shader code on these files here, and what I'm gonna do is just create another functionality on this class that creates a new program. And so first thing I'm gonna do is just create another function here. So I'm just gonna pass this thing here, probably points. This is an issue though. I guess I can create other. The easiest way is just to do that, I think. So I was thinking about this thing here. That's gonna be an issue because obviously I'm gonna cache the uniform values from the shader from the main mesh, the stuff related to the mesh, which is the sphere, the attributes from the sphere. The way that I'm caching the buffers. Then if I'm gonna separate them, obviously, but what I thought about is just put another, I just create another function that has a similar name and just copy the functionality, but that's probably not as, And this is kind of the issue because it doesn't feel very good. Because it doesn't make, I'm merging two different classes in one, so. This is the stuff that I was saying before on the last string. The tricky part about the downside of the way that I did is this. That because like it makes it a lot easier to understand what's going on, but when you wanna like I'm forced to put the functionality on the programs class, and then this makes it. I still think it's better though than the other approach, but it forces me to change the functionality on the rendering cycle to handle this stuff here. Because I think that the way that it makes most sense intuitively is just create two different program classes. Then obviously one handles the normal mesh, and the other one handles the label mesh. But maybe. Because the key is the shader code. That's the thing. I think that's the reason why they did it the way they did it on 3JS, where they are constructing the shader code based on strings, because there is this direct equivalency between the variance of the shaders, the amount of shaders you have, and the program class, because they're one-to-one. So if you do the program class in a generic way, where you build the string based on the parameters, then it allows you to encode the functionality that's going to be flexible on the programs class based on the string's variance. So like if I do it this way, then, but there's probably, I'm trying to think of what would be the good way to do this, because one approach is to just have like one shader and then just make it very generic and based on if-else conditions. But I think that's probably, it's gonna have like limitations, so I'm gonna have at some point to create other shaders depending on what I'm trying to do. So if I create other shader code, I'm probably gonna I'm gonna be forced to create other classes here. If I do it like this, where each class is designed to handle only one shader code at a time. Which I think it does make more sense if I do it the way that I'm doing. And then I have to encapsulate the code, or using multiple shaders, the logic on the programs class. But that's kind of annoying, because it becomes, for this example specifically, where I want to couple the label with the sphere, so there's less chances that I'm gonna have mistakes later on. It becomes more problematic, because by nature, the programs class, the logic that I'm gonna use to couple the things, like it is gonna increase the probability that I make mistakes. Because I'm gonna have to remember when I'm creating the programs to link them correctly on the programs class. So I need to create 2 separate programs, and then but maybe just for this case, I think is good enough to create 2 different programs inside of this program class. I'm gonna do it like this. So I'm gonna create 2 different programs first, and then after I separate all the logic for building the text with 2 different programs, then I'm gonna try to merge them on the same code. And I think that's probably the best, because it's not that big of a deal, I think, to separate different. I think coupling the label with the mesh is not that big of a deal, because I can encode the if-else, the control flow logic inside of the shader, and then make based on control flow logic here, whether or not the class has a label, then I can design the buffers based on that. And if I want to create something completely different, then it's okay to create other program classes to handle that. Because I think that if I do want to create other stuff that requires lighting or something like that, something completely different, then it makes sense to create another completely different class, because then by definition the things are going to be less coupled, I think. Yeah, but it depends on the circumstance, though. That's the thing. But for now, it's probably, I'm gonna do this. The thing is, I'm not really sure, because it might be a bunch of work. That's the problem. I want to avoid obviously doing all of this and then I have to change everything else later. So I'm just trying to think about if it makes sense or not. Because maybe it is better to just try to... Another thing I can do is separate the logic on the file here. Maybe that's the best approach. So before I do that, because I need to clarify the whole pipeline, I think, from building the shaders and updating the variables, creating the buffers, updating the variables, and then doing the draw calls. Once I have this functionality, I can think about how to merge. Yeah, but this is the problem. I have to separate them, I think, because this one is for 2D, and it is the same way that I was doing on the other one. So You render the stuff on 2D and then the text on 2D, because I think most libraries are for 2D and probably for creating text for 3D. It's just a waste of resources, I think. It's not very necessary, because the way that I was doing on the other one is you render the text on 2D and then you use quaternions. Or I'm not really sure. Don't remember very well the name of the thing. Not sure if I'm confusing quaternion. One way to do rotation is the Euler method that runs into gimbal lock, which is when two different planes of the coordinates align because of the nature of rotations, because the order of rotation matter. So when two different planes align, have gimbal lock, which becomes uncertain how to move the object out of that position. So in order to solve that, they use something on the complex plane that translates the coordinates from real plane to the complex plane and then to real plane again by using imaginary numbers, which are three numbers, three different imaginary numbers and one real number to do the rotation. So you can do that, and then you just rotate the text whatever way they move the camera, you rotate the text in the same way, and then the text is always going to be correct. But the problem is, like, the reason I'm thinking about this is because I'm going to have to change this GL position, because this is on 2D. Then the other one that I'm using is going to be the model view matrix, model view projection MVP matrix multiplication by the position to get the coordinates. So this is the biggest challenge, I think, here. So obviously it's going to be related to the camera, so. My question is how to clarify this. The view size, I assume that it's probably going to be the camera. So they're doing the vertex position by divided by the camera position. I think it's better to do this way that I'm doing, so I can clarify the questions on my mind, so when I look at the code, I know what to look for. So the goal, I think I have to merge the two somehow, but one approach is to just use this shader code, separate the programs, and create two different programs on the same program class, and then just do them separately and change the logic on the rendering cycle so that if the class has a label, I just draw based on the other shader. But then the problem with that is the camera. So I'm gonna have to set. But it's not that big of a deal if I can change the position based on the object 3D of the sphere and make both of the positions based on the object 3D. I think that the position of the label has to be relative to the position of the sphere, so I'm gonna make them dependent on each other. And then I add some variable to add flexibility if I want to, which is going to be a default variable. So it's going to be like sphere.x and sphere.y plus some variable that I put. And then based on that, when I move the position of the sphere is going to move the position of the label automatically because they're connected, I think, that way. But the question is what happens on the absolute coordinates and the coordinates from the camera. And I think that it doesn't matter that much because I think it does matter though, because the GL position is going to be the absolute position. So I have to understand what they are doing here. This is the question, is whether or not this matters to synchronize with the other way that I'm doing the other program. Because they both depend on the projection and the view matrix. I'll be right back. The tricky part about this is that maybe it doesn't depend. I was gonna say that like if the way that they do the calculation here changes the way that the drawing is made, then it is a problem, because obviously if I put the other one, it might fuck up the drawing. It becomes annoying if I do another variable here and then I make the condition to see whether or not the label is going to be the thing that is being drawn, and then based on that I change the way that I'm doing the gel position, because then I'm going to have to set the uniform, or probably the uniform every time. Ideally, I'm able to change this, to translate this into the other way that I'm doing the position. And then just set up an additional buffer that is going to handle the thing, because then when I do the draw call, and the problem is I'm going to have to do the 2 different draw calls anyway, because one uses indices, the other one doesn't. So they have to be on 2 separate VAOs as well. That's kind of the issue. I think the easiest way is just to connect them outside. So the question is, what is the best way to couple them together? So if I do 2 different programs, how can I couple them? So do I do it on the group, and then I just inherit the mesh on the label class, and then I just put them on the same group, and then I change the position based on the group, and then I think this is probably the best way. So I separate them into different programs. I'm gonna copy the code here and just paste there. So I separate them into different programs, and then in the main rendering cycle, I just check to see if it is a label. Yeah, but how? Because if I do it, the annoying thing about checking about the group is that I'm gonna have to change the functionality there. So if I make a check here based to see if it's a group or not, and then based on the group, I create the programs at the same time, then I have to change the way that I'm recursing here, I think. Because otherwise I'm gonna add the 2 different meshes twice. So the problem with creating another program is that I'm going to like create the 2 programs independently. So I'm gonna have to connect them some way. And either I will connect outside of the rendering cycle here, or I connect inside of the programs. So I have one separate class for the label, another one for the sphere, and then I connect them inside of the programs class. But that seems very bad to me, because then I have to keep track of all the connections. It's better if I view them as the same thing. But that's why I was thinking about doing on the sphere geometry, adding the label as a variable in the sphere geometry. But then it becomes this problem where either I create 2 different ways to create a program inside of the program class, and then I just use the same one. Because then the question is, what about the position? I'm gonna do like this. So I'm just gonna do two different. I think that's probably the easiest. I do two different programs on the same class. Yeah, so I'm just gonna create the same variables and just put the label. Just change the name to be label. Then I do a check. So the thing that I'm uncertain about is whether or not if I make the position of the... So I think that the easiest way is to change the position of the label based on the position of the sphere from outside of the shaders. So because the data is sent through the shaders here, the GL position, but it is going to be parsed. So that's kind of another thing. So I'm not really sure, because the problem is the camera. So I have to see how they are doing the camera here. If I have to change this, then it makes more sense to put them on the same program, I think. And the question that I have is, if the GL position allows me, if I can set the position outside of this, which I think I can. I think I can do it like this, and then I just set the position to be the position that it sends here to the vertex, which is probably the position to update attacks. If I just make that position related to the sphere, which is the relative position, that's gonna couple them on the same space on the screen, I think. And from that point, I just change the position of the group. So I put them both on a group on the thing, and then changing the position of the group is just gonna multiply the matrix outside of the shaders. And so it is as if the GL position is never changing, but it is changing because it's being multiplied by the on the scene graph that multiplies the matrices that determine how this is going to be updated. They are changing. So this is the main thing that I have to clarify now. How do they update the vertex in the view? I think I need to change this, because if I make it based on the object 3D and the mesh, I have to change the way that this is being updated to reflect the change in the position on the other way. So I don't think there's a chance, or there isn't anything I can do about this. I'm gonna separate the codes into first what I'm gonna do. I think there isn't anything I can do about this. Like, I have to change. Why is it saying this? It's already defined. What I don't have to change is the way that they send the data to create the shape, the actual shape of the tags. I think that's the thing that I don't have to change. But because the GL position is going to be the absolute position, like the calculation of the translation between the points that are going to be sent to create the geometry, which are the points relative to themselves, which is the way you structure the buffer to send the data. That doesn't change, but the absolute position, that's going to be the calculation done there, is going to change. So I think I have to change that anyway. So the question, so I think if I have to do that, then I probably should create everything on the same program. Because I'm gonna have to translate the information anyway, and the way that I'm gonna send the data is not gonna change. So it's just gonna be based on the vertex. And what I can do is just pass the z position as 0. Because on the other way, I'm passing as 0. And if I do like this, then I can use the same program to send the data to both of them. I'm gonna try to do it this way. So I don't understand why he's saying that this is defined. It should supposed to be declared here and defined here. Member function. Maybe when you declare on the header, you don't need to. When you define the header, you don't need to declare. That's because I changed the function here. And they're probably using more than one shader as well. This is diffuse shader. I'm thinking about asking ChatGPT, but I'm not really sure if it's probably should spend more time studying this. Should ask. So the question that I have is how, at what point is this defined? Like, do you define when you're updating the values on the shader, or you define when you're building? Like, how does that work? probably is easier to just test. I draw the thing and then after I do that, then I think about it. I think I'm not gonna be able to. I am, but it's gonna take massive amounts of time to change all the shader code so that I incorporate on the other one. I think it's not worth it. It's just better to create another thing. Create another program instead of the other one, and then I figure out how to change the position so that they are synchronized. I'm gonna have to do that on the external class, I think. And soon I'm gonna take a break as well. It's already getting tired. And probably the best thing to do is to just create another program. And the main thing to clarify is how do they update the variables and how do they create the buffers. That's what I have to understand now. I'm gonna see if he's gonna update the shaders, put them on the build directory. Not sure if I made a mistake here. I think it's on the other. Oh, there's two and ifs here. I don't understand why. Maybe it's a mistake. Or maybe it doesn't matter that much. I should close here. Oh no, this is from the other one. Understand now. Also here. As doesn't put there. So they are adding is similar way to 3JS. They are adding the header in the string here outside. What I can do is just copy this function, obviously. So let me think about this. I'm thinking about if I do this way of separating them into two different programs, then I need to know the path to the label class. So either I change on the programs the functionality, because if I change inside of the constructor of the program, then the path to drawing the label is going to be fixed. But I think that's not that big of a deal, because I'm probably always going to use the same shader code to render the labels. And if I have to pass as an argument, then it becomes more annoying. So I think probably better is just to pass an absolute path. I see how I did this path there, and then just access the path in a function instead of this. Create another function here, then call that function from the constructor, and then inside of this function here I just get the fixed path to the label. I think that's probably the best thing to do. The trickiest part is the thing about the position, that I'm not sure if it's gonna work out or not. Because I have to think about I don't know if I should, because if I start copying what I'm thinking about is just copying these functions to add the functionality to create everything related to the label, and then I just add different variables that are going to be equivalent to the variables of the other program, but for the label. So just creates something. I don't understand why they do this here. On the other one, it deletes the shaders after it creates the program. It's probably because of some functionality there. So the biggest downside of copying everything is that if I get to the point, when I get to the point that I'm going to draw the text, if I realize that the position doesn't work out, then I'm going to have to remove everything again. So I'm trying to think about... Obviously I could use Git to version control, but... So I'm gonna write on SkyDraw the functions, like the order that's, yeah. So write the order, then I have to understand how the view works. I think that's the main thing. Because I don't want to have to change the data that I'm passing to create the geometry. I think that doesn't make sense. So the only other thing there is that is multiplying by the view to get the coordinates. I'm gonna write down these functions, this sequence on the thing is I don't even know. I'm gonna try to follow the flow there, and then write the sequence of the execution to draw something, to draw the label. So understand what kind of data that's I think the most important part is the position. How are they updating the position inside of the shader so that the text goes on the screen? Because that's the main thing that's is gonna be conflicting there. So the question is the relationship between the label position and the sphere position, because they're being done, and that obviously affects everything else because of the design of the shader and everything. I think this is just a calculation to go from the coordinates of the label to the coordinates of the screen by incorporating the view size, which is going to be either something related to the camera or something related to the screen itself, GLW screen. So I'm gonna start from the beginning there, the function that is used to create a context in the first place. Which I forgot where it is. And this is kind of confusing. Then putting that in the params and then sending this here. So it's gonna call this function passing that as an argument. So it's passing the context that is inside of the params from this context outside here. I think the main context is gonna be this one. I think is that I'm probably gonna need to use this context as well. That's the thing. Because they are holding the images here, the fonts images. And I assume that this on this call here is just gonna create the shaders, and then if we return 0, it means that something went wrong, so we go should error. So let me think about it. And then it calls this function to create the texture. Like one thing that I can do is just put this context inside of the program class. That doesn't make sense. It has to be inside of the label class. I can put the context inside of the label and then just do the same stuff here. So I get these functions one by one, and then I just translate them into the label class. And I keep track of the context inside of the label class. The trickiest part is the position of the shader that I'm not sure. So the position depends on the view. So like the challenging part is the how to synchronize the position of the sphere with the position of the label. I think everything else I can just copy. Where is this? Ah, it's probably here. So this is going to be the other context inside of the params, and creates another pointer. It's kind of confusing to be honest. And this one creates. So they're using this shader structure to store the values of the uniforms from the shader. And so view size, shader prong. It's just a program. So it's storing the values of the variables instead of the shader thing here. The variables of the shaders. And it's not using a... Oh, this is the vertex array. And this is the context. The easiest thing to do is just gonna be a copy. So that's what I think I'm gonna do. I'm gonna put all this functionality on the label class. Then inside of the programs class, I'm just gonna check to see if the geometry has a label. And if it has, it just sets things up based on these functions that are gonna be inside of the label. And then on the main rendering cycle, I'm gonna check based on the geometry. Yeah, I think that's the way probably. So the biggest question is the position. So I have to see how to... it's just gonna be the easiest way. So I'm gonna have to figure out how to couple or how to change the position from the sphere. So make the position of the label dependent on the sphere, and then how... Because it's just gonna be a calculation. If it's not the same position that they are doing inside of the shader there, like I can find some way to do some math and translate the position from that one to the sphere. So like they are synchronized with the object 3D thing. Yeah, it's gonna be an equation. So just the position of the sphere itself. The problem is that the sphere, so it has to be on the mesh, but if it is on the mesh, it's not very good. It has to be on the sphere. Let me continue to follow this, but I understand how it works. It's very similar to the other way. You're just creating the shaders, then create the buffers. Like, obviously, it's going to be similar, but... Atlas, as far as I remember, is like is a way to optimize the pictures that you're using to render each character. Because you can imagine that for each character, you're gonna have a different picture that represents the geometry of the character. And the Atlas, I think, puts them all together so you can do everything at once. But I don't remember really well exactly what are the differences. It doesn't matter that much to me. Let me go back to the other, to this one. I have to see if they are setting the value, like an initial value for the view on this one, on the buffers. And they create the shaders, create the vertex array, uniform. It doesn't look like they are setting anything here, so it's probably gonna happen. So now I understand. So the first function, they just update the values of the struct with whatever. So create the program, create the buffers, put everything on the context, which is the struct that is gonna hold the state, and initialize the pictures that are gonna be used to update the textures inside of the shader. And that's what they're doing in the beginning. And then they're probably gonna update the values of the variables when it gets time to draw the label. But as I'm missing something here, because it should be on when they create these buffers here. And this is just the fragments buffer, vertex buffer here. Yeah, you shouldn't be here because there isn't anything. So they're just creating the buffers here, and they're probably gonna update the attributes thing somewhere when it gets time to draw this stuff. As far as this one goes, I think that's all that's happening here. Here, so the main one is gonna be begin path. But I think with the label, it's probably better to go off the label example. So it receives the context and then just calls this thing. Sets the attributes. So obviously they're using this struct state inside of the context to hold the states of the thing that is going to be drawn. Trying to find the function that it's probably going to be the render text there. They set the buffers. I'm not sure where does the view, where is the view updated here? This is gonna be the position of the points based on the image, I assume. And then it's gonna use that to on the draw call there to draw, to send the data, but there isn't anything, unless I'm probably missing something. There isn't anything related to the view image thing. View size. It's probably set on the context, and I just missed. That should be this thing. So once I clarify what is how is the view size going to be updated, then I'm just going to copy everything. So I'm going to put the logic, all this logic here to build everything inside of the labels class, and just copy all the things. Then hold the state inside of the label, and initialize everything on the programs, like call these functions on the programs based on the sequence that they are doing here. So I'm not really sure if I'm gonna do this on stream. I'm probably gonna do it off stream, but I'm just gonna clarify this. But yeah, I'm gonna do the drawing on the scatter draw of the sequence of the flow of the execution to create the context and everything. Then copy the stuff on the copy each function that's gonna be used. Put everything inside of the label class. Then once I have the flow of execution, I can just go one by one, and inside of the program class, I put a condition that if the sphere has the label, if the label was initialized, I can make a Boolean variable to make it easier inside of the sphere. Then if it has the label class, then I call all these functions, build the program, and then inside of the rendering cycle, I just put another condition to check if the geometry has a label or not. And if it does, then I just do the draw call function here that they do it. It's probably not going to be very hard, but the biggest thing is the position. So the question is like, so there's two questions. One, whether or not I should initialize the label inside of the sphere geometry. And two, what is the best way to update the position? Because the position of the geometry of the sphere is based on the mesh. But I don't want to put the label inside of the mesh because then it couples them together, and that's not very good. I prefer to just couple with like specific geometry, but maybe I'm not really sure if it matters that much, to be honest. Because maybe I can put, if I put on the mesh, then I think it's easier because the mesh is the thing that inherits from object 3D, which has the position of the absolute. So because I'm going to be using two differentiators because it's just easier. And I think I kind of have to because of the way that they do it. Unless I want to put a bunch of additional if-else statements and spend a bunch of time figuring out how to change all the logic so that once it's time to render the label, I just put everything. So it's too complicated. I don't think it's worth it. It's just better to do two different programs. But then since one of the programs uses one equation to calculate the position, I have to understand how do they the vertexes position that they are standing is just the points related to themselves that are going to make the geometry. So the thing that matters is the view size, which I think is going to be based on the GLFW view window. And if that's the case, then and it's probably good. Maybe that's what I should look for here is which kind of function that they are using to specify the position of the text. It's probably this one here. So XY, so this one. So I have to think about, so what I'm thinking about as well is just copying this and putting inside of the label. Then based on that, I am going to create another function that I have to think about this. So this is the question. If I change, if I make the, I think that's gonna be the case. If I make the position of the label dependent on the position of the sphere, then when it change the position of the sphere, is automatically gonna change the position of the label as well. So here in the way that I'm doing here, the problem is that this position comes from the mesh, not from the sphere. That's the thing. This is the thing that is because the sphere here is not the geometry, it's the mesh. So if I do it this way, I think I have to put the label on the mesh, not the sphere. That's kind of the problem. And maybe it's not that big of a deal. I think it's just easier, so that's what I'm gonna do. So put the label on the mesh, not the sphere. If the mesh has the label, then I just do this stuff here. I make the label class. I create a function inside of the mesh that sets the label. And that function initializes the label. The constructor just puts an empty constructor on the label, so that I don't have to initialize as I initialize the mesh. And then I initialize all the properties of the label, which is going to be the context and everything. So follow the execution from NanoVG, puts everything on a function, the setup for the context, or just call that function that has the setup. Then that's going to initialize everything, the states there. And then I put the question would be how I do it so I don't have to call the draw label. I can just, by changing the position of the mesh, it automatically changes the position of the label without having to call any functions. I'm gonna do everything first, then I think about this. Because I think there's not gonna be a way, but then it's kind of bad. Because I have to, unless I make some complicated thing with event listeners, even if I initialize the position, because the way that he did it, is not gonna draw the thing, unless you call the function, I think. That's the problem. So unless I call the draw label function, it's not gonna draw anything. So that's the thing that I have to change. Let me continue this. I think I'm gonna do the other stuff first, then I'll think about this once I have the class, everything set up. So stars here. Gel is the context. And so I assume that here is gonna update the uniform value of the view size with this gel view here. So now let me go back to the execution. I'm gonna see when this is initialized. It's grading turn. So it doesn't seem like it's grading. It's graded when you draw, or is render grades here? You're just gonna create the shaders. It's better to search for the thing, I think. And render viewports. weird that it doesn't set in the beginning here though. So I think that the only thing that makes sense is that it's gonna... I'm not really sure if it's necessary to call this before calling that example function there. Maybe it's on the function that initializes the states. Oh, I guess it's gonna be the value passed there. So the xy is not the... but the name is kind of weird if that's the case. I'll be right back. I think I figure out. I clarify my mind. So the way that it's gonna work is better. It's just easier to put on the label on the mesh. Like the downside of doing that, the way that I was thinking is that maybe I'll have a lot of different meshes that are not necessarily gonna have a label. So the problem is that every time that I create a mesh, it's gonna increase the memory that I'm using, because I'm gonna declare the label on the mesh and not the geometry. Maybe there's a way, another way to do it. Actually, I don't need. Maybe it's better to put on the geometry. So, but all that I have to do. Actually, I'm gonna put on the geometry because what I can do is initialize the label as, so I'm gonna have inside of the mesh, I'm gonna put a function that is called set or label. And then on this function, I'm going to, so here is going to receive a string. Yeah, then here I access the shared geometry, or I just access the geometry, and then I initialize the label here. Or I put some function inside of the label. Let me think. The main thing that I have to, I'm going to put a variable inside of the label class that is going to be the mesh position. So, but I'm going to pass a pointer, I think. So I initialize a share pointer to the mesh in the label. I'm not really sure if that's good. And then I make the position. So the way that I think this works, I don't know for sure, but based on everything that I've seen here, is probably the x and y here. This x and y is going to be the values that the coordinates you pass to determine where the label is going to be done. And the other value on the vertex is just going to be the positions that are used to create the geometry. So the view size is just the values you pass to determine where the thing is going to be rendered, and it's just 2D coordinates. So what I can do is just initialize a position based on the base position is going to be the position of the geometry, of the mesh of the geometry. And then based on that, I put the x, the baseline is going to be the position of the sphere or the geometry from the mesh. And then the x and y is going to be just the offset based on that. So the relative position. I think that's probably the best way. And then I just obviously copy everything from this one and just put inside of the label class on the other one. But I'm not really sure what is the best way to initialize a position instead of the label. Because the mesh is the thing that has a position, and the mesh has the sphere geometry. But I want to make the label as a variable of the geometry, not the mesh. But it has to change as the mesh changes. That's the thing. So like I don't have to think about changing the position of the label, obviously. The easiest thing to do is just pass the mesh, a pointer to the mesh. But I'm not really sure if that's very good. Or maybe this X and Y is not it's just the size of the font, not the position in the screen. Oh, it is the position on the screen. That's the only thing that makes sense. Hmm. Yeah, I understand everything now. And then this is gonna be the thing that draws. I think this is for transforming the coordinates to screen coordinates because they are inverse. It's probably not really sure. I think that's it. I'm gonna stop here probably. So already I clarify everything. So what I'm gonna do is just create the class, then follow the execution, put all the functions. So I'm gonna follow the context first, create the context. Then I'm gonna go from this function here. And then I'm gonna follow the execution of this one and just put all these functions on the label class. The main thing that I'm not 100% sure is the position. So now I'm fairly confident that this is gonna be the actual position that you pass to determine where the thing is gonna be drawn. So I have to connect this with the mesh class, so they are dependent on each other. And then I'm just gonna create another program because I think that's easier. So I'm gonna put a condition inside of the programs class, or the program class, that checks to see if the label was initialized, or if the mesh has a label. And if it does have the label, then I call the functions from the label class to initialize everything, initialize the program, and then on the main rendering cycle, I'm gonna add here on the loop also another condition to check to see if the program has, if the mesh from the program has, or the geometry has the label. Yeah, I'm gonna spend some time thinking about what is the best way to connect the two. So it's probably gonna be, I'm thinking about The only thing that I'm not really sure about the share pointer is that it feels kind of weird because the label is going to be a variable instead of the geometry. So, but I think that's the only thing that makes sense. I initialize the label, or I initialize the positions of the label using a share pointer to the mesh position, to the mesh, and then I access the position from the mesh instead of the label. Because that way, when I change the position of the mesh, it's going to automatically change the position of the label. And then I move them from inside. And then the relative position that I use to set the label on the mesh function here, I put the x and y. This is going to be relative to the geometry. So maybe I should put z as well. So one thing that I can do is just that's going to be another thing, is how to make sure that the z position and the rotation is working, because I'm going to do the operations from the mesh. Another way would be to just make the label class inherit from a mesh or from Object3D, and then put them inside of a group, and then I change the position of the group. Maybe this way is better, I think. That's the way that I was doing on the front end. Maybe that's better. And then I don't put them on the geometry class. I just make a separate class, inherit from Object3D. Yeah, that's probably better actually. 'Cause this way would be better if I use the same program, but since I think I'm gonna have to use separate programs, otherwise it's gonna be too much work. I think it's probably better to just put everything on the label class, and then I just inherit from Object2D, put them on a group, and then I pass the group. I change the position of the group when I change the object. That's how I was doing. And then on the initialization of the label class, I just make it based. I just pass the position of the mesh that has the sphere. I think that's probably the best way. So yeah, that's probably what I'm gonna do. So I'm gonna do this off screen, and next time I'm gonna continue to follow this list here. So the next thing to do is to create camera, if everything works obviously. The next thing is to create camera controls and anti-aliasing. Once I finish this, I don't think I'm gonna do this optimization thing. I'm just gonna move on to creating the graph. And once I have the graph, then I can start. I'm gonna incorporate everything with IMGUI, and then start thinking about the other parts, which is to get the data and create the graph based on the data. So